Welcome to Energy Central Power Perspectives Podcast, the show that brings leading minds from the energy industry to discuss the challenges and trends that are transforming and modernizing our energy system. And a quick thank you to West Monroe, our sponsor of today's show. Now, let's talk energy. I'm Jason Price, Energy Central Podcast host and director with West Monroe, coming to you from New York City. And with me, as always, from Orlando, Florida, is Energy Central producer and community manager, Matt Chester. Matt, as the utility sector seeks to continually decarbonize, more renewable energy resources means we need more battery energy storage systems as well. While the rate of grid-tied battery installations has increased to unprecedented levels, and that rate of growth is poised to only accelerate, prevalence of batteries on the grid brings with it new challenges. One of those key areas that is critical for utilities to be thinking about today is preventing fires at battery sites and ensuring fire safety is at top of mind. Matt, can you share some background about the safety related to battery energy storage systems?
Sure, Jason. So the issue of fire safety around batteries is particularly important because the technology typically used, the lithium ion, has some specific areas that must be kept in mind when it comes to safety. The chemicals used in these batteries bring with them risk of thermal runaway, which is a fire inside the battery that can't be put out with conventional methods. And while generally the likelihood that fires would start in systems housing these batteries isn't necessarily any greater than at any other utility facility, with some estimates that a lithium battery fire has the odds of about 1 in 10 million, the potential risks once those fires are started can lead to large safety concerns as teams fighting those fires are simultaneously dealing with the risk of reignition, electric shock, and even toxic fumes. That said, effective fire prevention practices and proper emergency response preparation can mitigate these concerns.
That's great, Matt. Thank you for that. So indeed, this is a situation where utilities would do well to lean into the ounce of prevention. And our guest today is perhaps the leading voice when it comes to espousing proper preparation for lithium-ion battery fire safety at utilities. Joining us today is Jay Sadler, the Energy Storage Operations Manager at Duke Energy. Jay comes from a background that combines both the firefighting industry and the nuclear generation sector. So he's indeed uniquely positioned to understand the technologies, procedures, and best practices. And as Duke Energy continues to grow its energy storage footprint, Jay is leading the enterprise and doing so responsibly, while also sharing those key insights with peers across the utility industry. Jay, thanks so much for being here, and welcome to the Energy Central Power Perspectives Podcast.
Thank you very much for having me. I'm excited to join.
And we are thrilled to have you. So, Jay, let's dive in. We want to talk about fire safety aspects in our conversation. And I'd love if you could paint a picture for our listeners about what these energy storage facilities look like, since the need to respond to a small EV battery fire is no doubt very different from what you address at a larger scale energy storage installation.
Sure. So my group at Duke Energy, we operate and maintain distribution-tied battery energy storage systems. You may hear me refer to it as a BESS system. That's the acronym. You know, in the utility industry, we love to use acronyms. So our sites are smaller footprint than that of a transmission-tied site. Our sites are usually between 1 to 2 acres, and our energy storage systems are typically less than 20 megawatts. In one of our sites, you may have anywhere from 1 to 8 50-foot shipping containers, or up to 100 of these small modular type containers. They're normally 4 foot by 4 foot by 8 foot tall containers. These containers will feed underground to an inverter, then it'll go through a step-up transformer, through the switchgear, and out to the distribution line. On these sites, there's also a site control center that houses all the communication equipment and the UPS system. We also have an auxiliary transformer that powers HVAC for the containers in the site control center. So our sites are a small site. You may find them out in the middle of a rural area, or you may find them in a city center somewhere around local city. But most of our sites, or in fact, all of our sites are distribution tied.
All right. You describe them as small, but these are pretty, acid intense and sophisticated technology. So share with our audience, what are the inherent risks of such batteries?
Well, we're using different forms of lithium ion batteries. We've been using what they call an NMC battery, which is a nickel, manganese, cobalt. We're also starting to use iron phosphorus batteries, lithium ion batteries. Both of them are lithium ion. Either way, they're still the same risk. It's a thermal runaway. A thermal runaway is a fire inside a lithium ion battery, and it cannot be put out. It's an exothermic reaction, and so it will feed on the chemicals inside the battery until there's no fuel or no chemicals left inside the cell to burn. To start this process, there has to be a fault. We need some kind of fault to occur, either an overcharging event, an overheating event, or maybe even a short circuit. As that fault's taking place, the battery cells start heating up and start to build pressure internally. There's a vent on top of the battery cell, and it is when it hits that predetermined value of pressure inside the cell, the vent will rupture and it'll actually spew gases. These are not the kind of gases you want in an enclosure. These gases are going to be mainly hydrogen, carbon monoxide, carbon dioxide, methane, propane, a lot of the gases that you don't want inside an enclosed area. These gases can reach their explosive ranges very quickly. That next stage after the gas generation is going to be what we go into is thermal runaway. Again, that's a chemical reaction inside the cell. It can't be stopped and the fire cannot be extinguished. Even if we avoid thermal runaway with the safety systems to stop that fault, you still could have potential for large amounts of explosive gases inside this container. So that's what we're concerned about.
Talk to us about the baseline safety procedures, the protocols, or even the technologies that you use to address these areas of concern.
Sure. So our number one rule with our battery sites is we always preach do not enter the fence, the site fence, if there's a safety strobe or an audible alarm that's activated. That's our number one protocol, and I can promise you, any fireman who's attended any of my trainings can tell you that rule. I say it so many times. So let's kind of go through the safety systems that we utilize. First line of defense is going to be our battery management system. We only use the BMS brand, matching the brand of batteries we use. Next, we're going to use the Lion Tamer product. We thoroughly believe in this product. It was developed by the Navy for use on subs with lithium-ion batteries. They realized this inherent danger. And you can imagine that on a submarine, they wanted to make sure they tried to avoid thermal runaway on a sub. So they developed this product as an early detection system. And what it's doing is it's looking for venting cells, that gas coming out of the cells. For the next safety systems we have, we always use a network fire alarm control panel, smoke, thermal detectors. We actually utilize a hydrogen and carbon monoxide gas detection system. And we also utilize a dry chem suppression system. For anybody that caught that, I did say a suppression system. That's not to put out a thermal runaway. But there's a lot of electrical components inside of these containers, and you could just have a basic electrical fire. You don't want that electrical fire to, in turn, cause a thermal runaway with your battery. So if you had a basic electrical fire, you want to have a way to put out that fire so it doesn't lead into a battery thermal runaway fire. We also utilize ventilation systems. So we talked about a lot of gas generation from these cells as they're faulting. We want a way to purge those gases from the container. We utilize deflagration or blast panels on the roof of the container. If we did have a blast there, our safety systems failed, and we started building pressure inside one of these containers, we don't want the pressure, the blast, to go outward toward our fence and our first responders. We want it to go upward and keep our first responders safe. One of the other things we use is a fire department connection to flood the container in a worst case scenario. Flooding is not going to put out a thermal runaway, but it is going to cool all of the other battery modules or cells around the one that is in thermal runaway. And that's the whole purpose of it, is to cool everything down. One of the biggest things I'm most proud of is probably our first responder station. It came from several industry events where we realized, hey, we're telling the first responders to stay outside the fence. I mean, our first rule is do not enter the fence for fire response. Well, if we're telling them that, we need to provide them some kind of tools that they can use outside the fence. What we offer is a weatherproof box, and that houses your main fire alarm control panel, e-stops for each unit, ventilation controls, and then the fire department connection hookups are right beside this first responder station. So we want to give them that right outside the fence. And it also has warning strobes on the outside of the box. We standardized all our warning strobes across all Duke sites. So my group operates the distribution tide. There's another group in Duke that operates T-tide, and even our unregulated side, we're all standardizing our strobes. We use a white strobe for a general fire alarm. A blue strobe means that we've actually had suppression agent released inside a container. And then an amber strobe means that we have high gas. And that's standardized across our whole fleet, and it also is located on all the signage around the site as well. It's something that we're very, very proud of.
Jay, you alluded to some of what I was about to ask, and I'd like you to elaborate. Really, it's around the safety of the emergency responders who are going to be addressing this. So you gave a detailed and thorough response a moment ago about the technology. Can you share with us, what is the education process like on your end? And are such trainings taking place across the country as well? Or is this really, initiatives more local to you?
Well, the safety training is taking place in a lot of areas, but there's a lot of utilities that they're deploying this technology and they still don't understand the hazards. So I'm not going to quit spreading the word on how important this training is to everyone in the fire industry. We have a multi-layer approach. So we hold an initial meeting on site during the construction, and it's usually right after the major components have been set on the site. During this meeting, we're going to invite all the first responders, anybody that may respond to our site for a fire emergency. We're going to have them there on site. We're going to introduce them to lithium-ion technology. How does a battery energy storage system work? We're going to start talking about the hazards of the battery. We'll give them our first responder safety brochure. That's something we've developed. Inside it has pictures of site components, describes what is a BESS facility. It talks about the hazards of lithium-ion. It gives them some really good generic on-arrival instructions. In other words, what do they do when they get to the site if they're coming or responding to an event? Talks about some of the unique challenges of fire response to our BESS systems. Again, we talked about water doesn't put out a thermal runaway event, so they need to understand that theory. And then gives a warning strobe descriptions and our contact information. We always want to make sure they know how to get a hold of us. We ask them to put one of these brochures up on their visor of every one of their trucks. And believe it or not, they show up to the second training, probably about 50% of them standing there holding their brochures. So we know it's getting to them. They're understanding this is very important. We also discuss the 911 message. This is something we do for every one of our sites. And we actually contact the local 911 center. And what we're trying to do is get a message put into their CAD system. So when someone comes by and sees that something may have happened at our site and they call in and give our site address, a pre-canned message pops up for the 911 operator to give to the first responders. It's very important they know what they're responding to. That's been lessons learned from some of these events. The first responders didn't even know they were responding to a BESS facility. So our message states, it's got 5 bullets. First one is warning. You're responding to a Duke Energy large-scale battery energy storage facility. It's going to give them a code for our first responder station. We have to keep that locked so somebody just walking by can't start hitting e-stops on our equipment. So it's going to give them that code for that first responder station. Next thing, it's going to give them a contact information for our control room. Warning, site will remain energized even when disconnected from the grid. And the last thing is our number one rule, do not enter the site for fire response. So that's what we're going through in the first session. So second session, we're going to have the first responders back right before we take operational control of this facility. So during this session, we're going to actually do a lot of hands-on training. We're going to review safety data sheets, emergency action plans, hazard mitigation plans. We're also going to train the first responders on how to use the components in that first responder station. It doesn't do any good if we provide something, but we don't train them on how to use it. And then we'll do a full site tour. We'll talk all about the safety systems, we'll actually open up all the containers. We want to make sure they're comfortable understanding what we're doing there. Last thing we do is we provide a PowerPoint. This is something we actually got from a lessons learned from one of our first sites. One of the fire departments said, hey, we need something to put into our training program. We didn't think about it right off the bat, but a lot of these fire departments are volunteer fire departments. They have a high turnover rate, and so we need to have a way for them to incorporate our system and our hazards into their training program. So we actually give a PowerPoint that is site-specific. It's usually about 20 slides, but it just goes through all the components. Everything we discussed in training, it's in that PowerPoint. So it's been very well received.
Yeah, absolutely. You're taking us into the weeds. It is a very sophisticated and dangerous environment that you work in, and this level of detail that you're describing is just, I guess you could say, mind-boggling. I mean, it's just, there's so much here that we have to be aware of when dealing with this kind of technology. Which leads me to my next question, which is, it continues to rapidly evolve. There's new types of technology, new types of batteries. There's a lot under exploration, captures a lot of the popular press. So there seems to be a lot of money being poured in to looking at battery storage in a variety of ways and makeups. So how do you keep track and how do you stay ahead of this so that your protocols meet what's coming out on the market?
Well, that's the million-dollar question. It's extremely difficult to keep up with the emerging technologies. You know, everything's changing every day. We think we have something ready for deployment into construction and into operation, and then you turn around and everything's changed. One of the first things that's changing is the battery containers. Battery containers are getting smaller, which is a really, really good thing. Like I mentioned earlier, old typical sites would have shipping container size enclosures for our batteries. Now what we're seeing is small containers. Instead of shipping container that has 50 racks of batteries and may have up to 10,000 cells inside, we've got a container that has one rack of batteries and it may have only 400 cells. Why is that important, or why is that good? This reduces the amount of batteries in each container, and that reduces the potential fuel for a thermal runaway event. Also, in these smaller containers, there's not as much free airspace inside for the accumulation of explosive gases. Less gas buildup, the better. So these small containers are really, I think they're a great thing for the industry. I think you're going to see not many utilities utilizing the larger containers as we go forward. Most everybody is shifting over to those small containers. Another thing that's very important is some container manufacturers have realized the dangers, and they're actually incorporating a lot of the systems we require on large containers in these small designs. That's great. I mean, that's really big for a manufacturer to realize, hey, this is an inherent danger, and we need to incorporate these safety systems. That helps us with the integration of our requirements. On the flip side of that, though, you do have some manufacturers who are still fighting some of the, I won't say they were fighting the hazards because they do understand the hazards. They may not understand all of the safety systems and how they all work together. And so some manufacturers are reluctant to put in all the safety systems we want. Well, the problem with that is we have specifications to what we want in our system to be safe. Well, some of these manufacturers have actually said, hey, you'll void warranties if you go in and add these safety systems. So that poses a challenge. You know, you have to balance your long-term O&M versus your safety. So it's been a big challenge for us. We do thoroughly believe in the container flooding option for a last resort. I want to make sure that I keep the first responders outside the fence if there's a fire, but I give them a way to fight the fire so that they're not trying to spin outside the fence and squirt water into a little tiny hole where a fire may be coming out. We had to get creative. We were really having to get creative on some of these things. We actually had a site. We could not put a flooding option to actually flood the inside of the container. So what we did is we put big fire headers above the containers with sprinkler heads, and literally when the fire department hooks up, it just rains down on these small modular containers. It keeps the ones that are beside it, the adjacent containers, cool, and they're outdoor containers. If it rains on the other ones that aren't in a thermal runaway, it's not going to hurt them at all. It really did accomplish the task we needed to do, and like I said, we're having to get really creative with some of this stuff. NFPA 855 is our national fire protection code. That's for battery energy storage, fire safety. It was just passed for the utilities this summer. It's got a lot of good information in it. We're still trying to get a good firm grip on what that means for our future sites and maybe even for our operational sites that may not meet that code. So you've got code requirements that are changing. You've got designs that are changing. We're even looking at new battery technologies that may not be lithium ion. So it's a constantly evolving industry, and it takes a lot of focus to make sure you keep an eye on what's going on.
Yeah, I would say so. And, as I mentioned in the beginning of the introduction, in terms of your background, you come with nuclear energy and firefighting. I'd love if you could share a bit about how you found yourself at each of those areas and what was that light bulb moment for you in putting this together in the utility sector, to help define your career path.
Sure. So I started out as a volunteer fireman in my small hometown. I believe I was age 16 when I started. It was love at first time being a fireman. I really did enjoy being a fireman. I served for many years, but like with a lot of things, got married, started to have kids, and I just didn't have the time to be a fireman, a volunteer fireman, day to day. So I did have to leave. After a couple of years, I was invited back to serve on the board of directors for our local fire department, and that's a position I still hold today. I really do enjoy being around the fire service, being on the fire department as a board of director. It's just a position I really like to have. I graduated from UNC Charlotte with a major in civil engineering, and I spent the majority of my time after college actually in the construction industry. Then 2008 hit. Everybody knows what happened in 2008. Construction slowed down. So I was looking for a change of career. I was able to get a job with Duke at McGuire Nuclear Station as an operator. So I started that multi-year training program to be an operator. I worked at McGuire for 6 years. This was probably one of the best building blocks for my career. It provided me with such an understanding of procedures, like how they're written, how they're used. And so this is one of the best things for my career was actually starting out in nuclear because it really gave me a good foundation. One of the things that I did love about working at McGuire was I was able to serve as a member of the station fire brigade. So I was around the fire service even though I was still at work or just kept me involved with firefighting. After McGuire, I went to the Regulated Renewables Operations Center. This is our transmission tied renewables control room. There we operated all of the hydro fleet, the pump storage assets, all of our regulated transmission tied solar assets. I worked there for 3 years, and that's when it started dawning on me that there's a lot more to our company than nuclear. You work in nuclear and you kind of get in your little bubble and you think that's all the company is nuclear. And when I come out and started, I realized there's so much more, and I really realized how much renewables is starting to play a portion into our company strategy. And there's a lot of nuances to operating these facilities. So that was a great learning experience working in that control room. After that, I was invited to start our battery storage operations for Duke distribution. At that time, we only had one BESS facility in our unregulated branch, and I really quickly learned about the hazards of lithium-ion technology. At that time, when I started, there was an explosion about 2 weeks after I started. There was an explosion at a BESS facility out west. So I spent a lot of time trying to figure out what had happened and how could Duke prevent this from happening at our site. We had 2 sites in construction at the time. It was a really challenging time. There was only one other Duke employee who had any experience actively operating a battery. So he and I become really, really good friends. But we started looking at lessons learned, especially for operations, lessons learned for fire safety. And so we started creating operational procedures, fire safety specifications, emergency response plans. We just wanted to learn on how to operate these sites safely day to day. I have created a control room that we now operate all of our sites, and we operate sites in all our regulated jurisdiction, which is 6 states. And it's been a challenge. We love the challenge. We like running this technology. There's a lot of safety systems for it. There is a hazard with it, but there's a lot of safety systems that we deploy, and we feel like we're providing the safest product we can to the public and to our first responders.
That's quite a journey. No doubt you have the background to really, fit that this role. So it's amazing, the match. And you started out as a firefighter, so you must be in great shape. Were you ever on a calendar?
I was not on the calendar. My wife would really get a kick out of that one.
Being from New York City, the firefighter calendar is like one of the most popular. It's more popular than the New York Times. Let's put it that way. All right. This is a great conversation, and we're going to give you the last word. But first, we have something called the lightning round, where we pivot to a set of questions to learn more about Jay Sadler, the person, not Jay Sadler, the Duke Energy fire safety leader. So are you ready, Jay? Because the questions I'm going to ask you require either one word or phrase. Are you ready?
Absolutely. Let's do it.
Okay. What's your go-to movie snack?
Milk Duds.
Best vacation you've ever taken?
7 Mile Beach at Jamaica.
What historical figure would you invite to your dream dinner party?
George Washington.
What would be an alternative career path if you hadn't found yourself in the energy industry?
Site development, doing grading work. I love that.
What are you most passionate about?
First responder safety.
That's great. Well done. It was such a smooth performance in the lightning round. You've earned the traditional final word. So you're a man who's obviously passionate about safety, and you're often giving advice. So if there was a single tangible piece of advice each utility professional listening in today should heed, what would you like it to be?
Rule number 1, don't enter an energy storage facility fence. If there's any kind of alarm going off, smoke, fire, do not enter the fence. Stay outside, size up the situation, get a good game plan. These events are a long event. They're not a real short event. So you need to get a really good game plan, establish roles. You want to adjust that game plan based on the change in parameters. Things are going to change. I can't come up with every parameter that might change during an event. There's so many. So look at what's going on and change your game plan based on what's changing in the event at the time. And number one thing, stay safe. I just want to make sure that that's the number one goal every day. It's the number one goal for all of our employees, but it's the number one goal for anyone that comes to our site. Make sure you go home safe. We want you to come and go the exact same way, 100% safe. And if everybody stays safe, then we've done what we're supposed to do.
Great words, and thank you for sharing this. You know, as these systems continue to proliferate, I have to imagine that this is going to be just an ever increasing issue that every utility is going to really need to pay attention to. And Jay, I think that your words today and your leadership you're providing at Duke, I'm sure will work its way throughout the industry and in every corner of every utility that has a power system. So thank you so much for sharing your thoughts on today's episode and podcast.
Thank you very much for having me. It's been great.
You can always reach Jay through the Energy Central platform, where he welcomes your questions and comments. We also want to give a shout out of thanks to our sponsor of today's episode for making it possible. Thanks to West Monroe. West Monroe works with the nation's largest electric, gas, and water utilities in their telecommunication, grid modernization, and digital and workforce transformations. West Monroe brings a multidisciplinary team that blends utility, operations, and technology expertise to address modernizing aging infrastructure, advisory on transportation electrification, ADMS deployments, data and analytics, and cybersecurity. Once again, I'm your host, Jason Price. So plug in and stay fully charged in the discussion by hopping into the community at energycentral.com, and we'll see you next time at the Energy Central Power Perspectives Podcast.